So tutorial 9, we're going to look at using latex math notation, and we're going to do a classic type of GCSE question, a basic quadratic. So we're going to do it as a numerical question again. This time we're actually going to understand what we do with additional answers, because we're going to get two solutions because it's a quadratic. Okay, so I've got my keywords set up there, and as usual we're just going to write the question out as if we knew what the as if it's just one type of static question. So what are the roots of the quadratic x squared plus 3x plus 2 equals 0? Okay, so having written that out, we now want to think about how we generate random questions starting from that sort of basis. Okay, make that small x first of all. Well, the first thing I'm going to do is make this latex notation. So I just look at test question, that's where we've got so far. Let's make this into latex notation. Okay, by surrounding it by the curly brace asterisk and the asterisk curly brace. That is WIZZKWIZ specific. Usually latex notation is surrounded by dollars, but that interacts rather negatively with finance type questions, so I've changed that to curly brace asterisk asterisk curly brace, but you can see here, okay, that's worked fine. So now what we need to do is generate randomly the 3 and generate randomly the 2. Now, one of the big secrets of setting questions is you very rarely generate a random question. You normally generate a random answer and work out the question. So what we're going to do here is, let me expand that out, let me pull that down a bit, give ourselves a bit of space to work in. We're going to generate the actual roots first. So eval w alpha equals random step minus 4, 4, 1. So that's going to be one of the roots. Okay, let's see if that seems to work. Yeah, we've got random numbers generated there. Then let's generate the other root. Beta equals random step minus 4, 4, 1. And then what I'm going to do w blank equals, okay, because we don't want anything actually written at this point. So what this evaluate's going to do is going to get all the way to here, and this w blank equals empty space is just going to blank it out, so we don't actually see anything, because we don't want to write out w alpha and w beta. We just want to write out the values in here. Okay, so if you think about what this 3 is going to become and what this 2 is going to become, we need to now use our eval to put those expressions in. So this one, the units, is going to be w alpha times w beta. So let's try that. Okay, and we can see we're getting nicely generated random numbers there. At this point, okay, let's do this one first. So this is going to be minus w alpha minus w beta. You notice all these factorize. So at this point, to check it's all working, okay, not a bad idea to put in our answers. So again, we've got to evaluate, or we'll just write out the expression. Let's just actually show you. If I just write out w alpha there and don't put the evaluate, it just writes out w alpha, and it also comes up with a warning that answer is not numerical. Okay, and it tells you you might have forgotten to do that. Okay, which we have. So let's do that. Okay, and because this is a quadratic, we need an additional answer. So let's click that drop down and put in our other answer. Okay, now that's a bit weird. 1, 3. That's actually a 1 and a 3. So we've got to think about what these other things mean. So we want a separator which separates the two answers. So in this case it might be comma space. Okay, so we've now separated the two answers, as you can see down here. This is very, very important because if it's, say, coordinates or a fraction, it's important which way round it goes. If it's quadratic, it doesn't matter which way round it goes, so we don't click that. We leave that unselected. Otherwise, if the answer's 3 and 4, and a student puts in 4 and 3, they'll be marked it wrong. Okay, so it's very important that we don't put in that the order matters there. Prefix, we're not going to put anything here because it's not like pounds or dollars or something. Postfix, we're also not going to put in. Accuracy required. Since we're always going, the answer is always going to be a whole number, I could just have 0 there, but that would mean that if the answer's 5.2, or sorry, the answer's 5, it would mark 5.2 as right. So it's not a bad idea to just put, say, 3 decimal places in there. But I typically wouldn't display the accuracy in the question because it looks a bit weird, because you're just expecting somebody to put in the exact answer in this context. Okay, so let's see where we're up to now. So everything's looking reasonably good now. But the only downside is you've got things like this. Okay, you wouldn't write that expression. What you'd write there is x squared minus 9. So how do we do that? Well, if you think about the structure we've got here, that's pretty tricky. Okay, because we're telling it to write x squared, we're telling it to write minus alpha minus beta, we're telling it to write x, even if minus alpha minus beta is 0. So fortunately there is a magic way around this, and that is the tidy up function. So let me show you how the tidy up function works, and you can see it here, tidy up. So you put in the coefficient, what it's the coefficient of, the next coefficient, what it's the coefficient of, the next coefficient, what it's the coefficient of, and all that goes inside an eval, because it's a function that has to be evaluated. Okay, so tidy up. So the first coefficient is 1 in this case. What it's the coefficient of is x squared. The second coefficient is minus alpha minus beta. What it's the coefficient of is x. The third coefficient is w alpha times w beta. And what that's a coefficient of, you might think that, well, that's a coefficient of 1, but in terms of writing it out, it's a coefficient of just the empty inverted commas, because we don't want it to write a 1 after the 3. So in this case, we don't want minus 9 times 1. Okay, so let's look at what happens when we do that. Just going to put in a break there, carriage return. Okay, so that's not made any difference, but here you've got plus minus 4x, that's just an x squared minus 4x plus 3. Here's a classic one, x squared plus 0x plus minus 1. What you'd actually write is x squared minus 1. Okay, so that's what tidy up does. Really useful function. Now we want to put up the equals 0. Okay, so we're going to have to put that outside the eval, because we don't want that evaluating. We just want it to be written as equals 0. Okay, and now we can take that out. Okay, because we no longer want that in there. Okay, so now we've got a question that looks nice. Okay, the final thing we could do, if we want to, is put in the comments. Useful thing to put in here would be the actual factorization. Okay, so again, let's do it inside of latex notation, and we've got that backslash times that equals 0. Okay, and again inside here we can use the tidy up twice. Tidy up 1 comma x comma minus w alpha comma. Okay, but we've got to put that itself inside of the eval. Okay. And the same thing inside of there. But obviously that's now going to be W beta. Okay, so x squared minus 16 is 0. So that means x is going to be, x squared is 16, so x is plus or minus 4. So there you've got your two answers, 4 and minus 4. And that's because the factorization is x minus 4 times x plus 4. Okay, again, the only thing with the notation is it still looks a little bit crude, but that's a relatively minor feature compared to what we saw before. Okay. So let's submit the question and see if it's going to work out. Okay, so ID 3291. We're just going to shove that in there and test out whether this question works. What are the roots of the quadratic x squared minus 2x minus 8? Well, we can see immediately we've got two places to put our answers. Okay, so that's going to factorize into x minus 4, x plus 2. So the answer is going to be 4 and minus 2. Okay, because the quadratic factorizes like so. Try another one, x squared plus 3x plus 2, so that's going to be x plus 2, x plus 1, so minus 1, minus 2. Again, we've got that right. Okay, so we can see this question is working nicely as we would expect. That's going to be plus 4 and minus 1, or x plus 4, x minus 1. So 4 and minus 1 are going to be the roots. So I got that the wrong way around. So fortunately it's realized, so the roots would actually be x equals 1 and x equals minus 4. But you can see the system's working, the question's working. Okay. Then your comments there, you can put in whatever comment you want. Okay, so you can put in I like quadratics. If you're doing this question, submit your comment. Okay, and it'll thank you for your comment. And the next time somebody asks the question here, okay, so this time we've got x minus 4 and x minus 1, so the roots are 1 and 4. Submit, right answer. If you now click read other comments, you'll see the other comments gone there. So you'll eventually get a whole succession of comments of people discussing this particular question, whatever that particular question happens to be. So there we go. That's how to enter. There's quite a lot there. There's how to use latex notation, how to use the eval delimiter, how to use the tidy up function, and how to think about how to generate questions. Okay, so quite a lot of learning points in this tutorial.